Welcome to video 4.4, normal distribution calculations. So we've been doing normal distribution calculations with all our significance tests. And it's really just determining the probability of an event happening. So I included it with the probability section. So we have an example here. The number of daily views at statsmedic.com follows an approximately normal distribution with a mean of 15,000 and a standard deviation of 4,000. So what's important here are the words approximately normal. That means you want to find a z-score. All right, so we want to find the probability that a randomly selected day has more than 20,000 views. So more than means greater than. So to get this problem started, we want to draw our situation. So they said it was approximately normally distributed, so I'm going to draw a normal curve. And we're going to say it's approximately normal with a mean of 15,000 and a standard deviation of 4,000. So our mean is going to go right here in the middle. And the number I'm curious about what's the probability of being greater than 20,000 views. So on this curve, 20,000 would be to the right somewhere from 15,000. And I want more than that. So I'm talking about this shaded area right here. That's going to bring us to our first AP tip. And that is you should draw a picture for any normal distribution calculation and use it to make sure your final answer makes sense. So, and I'll show you what I mean by this. So make sure you're drawing this picture. It's a required piece and it will get you points when it comes to the FRQ. All right, so for this situation, we drew our picture. So let's go ahead and find our z-score. So when we find our z-score, we're going to take the statistic, which is 20,000, minus the parameter of 15,000, and divide it by the standard deviation of 4,000, which gives us a z-score of 1.25, which means this boundary right here is 1.25 standard deviations above the mean. So when I get out my handy dandy table B or table A and I go to 1.25, I get a z-score of 0.8944. So the area equals 0.8944. That seems like a big area for that shaded region. That's because we need to remember when we're looking up on table A, it shows you that the shading is being shown to the left. What we are actually looking for was on the right, so you have to remember to 1 minus. So by having that drawing, obviously this little section is not almost 90% of the data. It kind of helps remind you that you got to pay attention to this. So we got an area of 1056. 0.1056. That means about 10.5% of the views are more than 20,000 on any given day. All right, now how about how many views would there be in the bottom 5% of all days? So let's draw a curve. We're using the same information, so we still have a mean at 15,000. It's normally distributed with a mean of 15,000. Standard deviation of 4,000. Now, I'm wanting to know how many views would there be in the bottom 5% of the days. So really what I'm missing is my statistic. I know it's going to be over here because I want the bottom 5%. I don't know what this number is, but I want the bottom 5%. So we have our formula. That's our z-score equals your statistic minus your parameter divided by your standard deviation. So in this case, we could actually find out the z because we know we want the lower 5%. So we're going to go on to our table of values and find as close to 0.0500 as possible. And I find it So I got 0.0505, but I noticed that 0.0495 is the same distance from 0.0500. So it actually happens right exactly in the middle between these two numbers, between negative 1.64 and negative 1.65. So I'm going to use that as my z-score of negative 1.645. That's showing halfway between negative 1.64 and negative 1.65. Equals some number that we don't know what it is, minus the parameter of 15,000, divided by the standard deviation of 4,000. Then you have to use some algebra here, and when you solve it all out, you get x equals 8,420 views. Right, hopefully that was helpful. We'll hit it again when we talk about our significance test, so there'll be more z-scores and t-scores going on there. Let me know if you have any questions. I'll see you in class.